There is a lot of focus right now on building more models, but you know, building good products on top of these models is incredibly difficult.
Well, I would love it if you were comfortable giving kind of the longer form of your background, what brought you to OpenAI, just kind of bring us up to speed, and then we'll go from there.
Yeah, so I was born in Albania just after the fall of communism. Very interesting times in this, very isolated country, sort of similar to North Korea today. And I bring that up because it was, I think, very central to sort of my uh, education and focus in math and sciences, because there was a lot of focus on math and physics in post-communist Albania, and the humanities like history and sociology and these type of topics, they were a bit questionable. Like the source of information and truthfulness was hard. It was ambiguous. So anyway, I got very interested in math and sciences, and that's what I pursued relentlessly until still working fundamentally in mathematics. And over time, my interests grew more from the theoretical space into actually building things and figuring out how to apply that knowledge to build stuff. And I studied mechanical engineering, and went on to work in aerospace as an engineer, and then joined Tesla shortly after, where I spent a few years. Initially, I joined to work on Model S dual motor, and then I went on to Model X from the early days of the initial design, and eventually led the whole program to launch. And this is when I got very interested in applications of AI, specifically with autopilot. And so I started thinking more and more about different applications of AI. Okay, what happens when you're using AI and computer vision in a different domain, instead of autopilot? And after Tesla, I went on to work on augmented reality and virtual reality, because I just wanted to get experience with different domains. And I thought at the time that it was the right time to actually work on spatial computing. Obviously, in retrospect, too early back then. But anyways, I learned a lot about the limitations of pushing this technology to the practicality of using it every day. And at this point, I started thinking more about what happens if you just focus on the generality, like forget the competence in different domains and just focus on generality. And there were two places at the time that were laser focused on this issue, and OpenAI and DeepMind. And I was very drawn to OpenAI because of its mission, and I felt like there's not going to be a more important technology that we all build than AGI. Back then, I certainly did not have the same conviction about it as I do now. But I thought that fundamentally, if you're building intelligence, it is such a core unit in the universe. It affects everything, and so what else is there to do more inspiring than elevate and increase collective intelligence of humanity.
Whenever I meet somebody that's a real influencer and has done major contributions to the space, they almost invariably have a physics background or a math background, which is actually very different than it was 15 years ago. Like 15 years ago, it was like, the kind of, it was like engineers and, they came from electrical engineering, mechanical engineering. But it does feel like there's something, and I don't know if it's like some like quirk in the network or like it's more fundamental, like systemic. And I mean, do you think that this is kind of the time for the physicists to step up and kind of contribute to computer science? And there's something about that, or do you think it's just more of a coincidence?
So I think maybe one thing to draw on from the theoretical space of math, um, but also the kind of the nature of problems with math is that, you know, you kind of need to sit with a problem for a really long time. And you have to think about it. Sometimes you sleep and you wake up and you have a new idea. And over the course of maybe a few days, sometimes, or weeks, you get to the final solution. And so it's not like a quick reward.
Yeah.
And sometimes it's not this iterative thing. And I think it's almost like a different way of thinking where you're building an intuition, but also a sort of discipline to sit with the problem and have faith that you're going to solve it. And over time, you build an intuition on what problem is the right problem to actually work on.
So do you think it's now more of a systems problem, more like kind of more of an engineering problem, or do you think that we still have a lot of like kind of pretty real kind of science to unlock?
Both. I think the systems and the engineering problem is massive.
Yeah. Yeah.
As we're deploying these technologies out there, and we're trying to scale them, we're trying to make them more efficient. We're trying to make them easily accessible, so you don't need to have, to know the intricacies of ML in order to use them. And actually, you can see sort of the contrast between making these models available through an API and making the technology available through ChatGPT.
Yeah.
It's fundamentally the same technology, maybe with a small difference with reinforcement learning with human feedback for ChatGPT, but it's fundamentally the same technology, and the reaction and the ability to grab people's imagination and to get them to just use the technology every day is totally different.
I also think the API for ChatGPT is such an interesting thing. So I
Mm.
program against these models myself for fun, right? And it always feels like whenever I'm using one of these models in a program, I'm like I'm wrapping a supercomputer with an abacus. It's like the code itself just seems so kind of flimsy compared to the model that it's wrapping. Sometimes I'm like, listen, I'm just going to give the model like a keyboard and a mouse and let it do the programming, and then actually the API is going to be English, and I'll just tell it what to do and it'll do all the programming.
Mhm.
And I'm just kind of curious, as you designed stuff like ChatGPT, do you view that over time the actual interface is going to be like the like natural languages, or do you think that there's
Yeah.
still a big role for programs?
The programming is becoming less abstract, where we can actually talk to computers in high bandwidth in natural language. But another vector is one where we're using the technology, and the technology is helping us understand how to actually collaborate with it, versus program it.
Yeah.
And I think there is definitely the layer of programming becoming easier, more accessible, because you can program things in natural language. But then there is also this other side, which we've seen with ChatGPT,
Yeah.
that you can actually collaborate with the model as if it was a companion, a partner, coworker.
Yeah. I mean, that's the interesting thing. Like, it'll be very interesting to see what happens over time. Like, you've made the decision to have an API and whatever, but like, you don't like have an API to a coworker, right? Like, you talk to a coworker. So it could be the case that like over time these things evolve into like you just speak natural languages, or do you think it will always be a component of a finite state machine, a traditional computer, etc.?
Yeah, I think this is right now an inflection point where we're sort of, redefining how we interact with digital information,
Yeah. Yeah.
and it's through the form of these AI systems that we collaborate with, and maybe we have several of them, and maybe they all have different competencies, and maybe we have a general one that kind of follows us around everywhere, knows everything about my context, what I've been up to today, what my goals are, sort of in life, at work, and kind of guides me through and coaches me and so on. And, you can imagine that being super, super powerful. So
Yeah.
I think we are right now at this inflection point of redefining what
Yeah.
this looks like. Um, but, there is also, we don't know exactly what the future looks like. And so we are trying to make this tools available and the technology available to a lot of other people so they can experiment and we can see what happens.
Yeah.
It's a strategy that we've been using from the beginning, and also with ChatGPT, where, the week before we were worried that it wasn't good enough. And we also, what happened, we put it out there and then people told us it is good enough to discover new use cases. And you see all these emergent use cases that I know you've written about. And that's what happens when you make this stuff accessible and easy to use and put it in the hands of everyone.
So this leads to my next question, which is, um, so you invent cold fusion, and then part of it, you're like, okay, listen, I'll just give people like electrical outlets and they'll use the energy. But like, I think when it comes to AI, people don't really know how to think about it yet. And so like, there has to be some guidance. Like you have to make
Yeah.
some choices. And so, you're in OpenAI, you have to decide what to work on next. Boy, if you could like walk through that decision process, like how do you decide like what to work on or what to focus on or what to release or how to position it?
If you consider how ChatGPT was born, it was not born as a product that we wanted to put out there. In fact, the real roots of it go back to like more than 5 years ago, when we were thinking about how do you make these safe AI systems, and you don't necessarily want humans to actually write the goal functions, because you don't want to use proxies for complex goal functions, or you don't want to get it wrong. It could be very dangerous. This is where reinforcement learning with human feedback was developed, where what we were trying to really achieve was to align the AI system to human values and get it to receive human feedback. And based on that human feedback, it would be more likely to do the right thing, less likely to do the thing that you don't want it to do. And after we developed GPT-3 and we put it out there in the API, this was the first time that we actually had safety research become practical into the real world. And this happened through instruction following models. So we use this method to basically take prompts from customers using the API. And then we had contractors generate feedback for the model to learn from. And we fine-tuned the model on this data and built instruction following models that were much more likely to follow the intent of the user and to do the thing that you actually want it to do. And so this was very powerful, because AI safety was not just this theoretical concept that you sit around and you talk about, but it actually became, was sort of going into AI safety systems now. Like, how do you integrate this into the real world? And obviously, with large language models, we see great representation of concepts, ideas of the real world, but on the output front, there are a lot of issues. And one of the biggest ones is obviously hallucinations. And so we had been studying the issue of hallucinations, truthfulness. How do you get these models to express uncertainty? The precursor to ChatGPT was actually another project that we called WebGPT, and it used retrieval to be able to get information and cite sources. And so this project then eventually turned into ChatGPT, because we thought that dialogue was really special, because it allows you to sort of, ask questions, to correct the other person, to express uncertainty. There's just so much.
Found the error because you're interacting, and so
Exactly, there is this interaction, and you can get to a deeper truth. And so anyway, we started going down this path, and at the time we were doing this with GPT-3 and then GPT 3.5. And we were very excited about this from a safety perspective. But one thing that people forget is that actually at this time we had already trained GPT-4. And so internally at OpenAI, we were very excited about GPT-4 and sort of put ChatGPT in the rearview mirror. And then, we kind of realized, okay, we're going to take 6 months to focus on alignment and safety of GPT-4. And we started thinking about things that we could do. And one of the main things was actually to put ChatGPT in the hands of researchers out there that could give us feedback, since we had this dialogue modality. And so this was the original intent, to actually get feedback from researchers and use it to make GPT-4 more aligned and safer and more robust, more reliable.
I mean, just for clarity, when you say aligned and safety, do you include in that like correct and does what it wants, or do you mean safety, like actual like protecting from some sort of harm?
By alignment, I generally mean that it aligns with the user's intent. So it does exactly the thing that you want it to do. But safety includes other things as well, like misuse, where the user is, intentionally trying to use the model to create harmful outputs. So yeah, we were trying in this case with ChatGPT, we were actually trying to make the model more likely to do the thing that you want it to do, to make it more aligned. And we also wanted to figure out the issue of hallucinations, which is obviously an extremely hard problem. But I do think that with this method of reinforcement learning with human feedback, maybe that is all we need if we push this hard enough.
So there was no grand plan. It was literally like, what do we need to do to like get to AGI, and it's just one step after the
That's
other.
right, yes. And it's, all the little decisions that you make along the way. But maybe what made it more likely to happen is the fact that we did make a strategic decision a couple of years ago to pursue product.
Yeah.
And we did this because we thought it was actually crucial to figure out how to deploy these models in the real world.
Yeah.
And it would not be possible to just, sit in a lab and develop this thing in a vacuum without feedback from users from the real world.
Yeah.
So that was the hypothesis. And I think that helped us along the way make some of these decisions, build the underlying infrastructure so that we could actually eventually deploy things like ChatGPT.
I mean, I would love if you would riff on scaling laws. I think this is the big question that everybody has. Like, I mean, like the pace of progress has been phenomenal, and you would love to think that the graph always does this, but like the history of AI seems to be that like you hit diminishing returns at some point and it's not parametric. It kind of like tapers off. And so from your standpoint was probably like the most informed vantage point in the entire industry. Do you think the scaling laws are going to hold and we're going to continue to see advancements, or do you think we're hitting diminishing returns?
So there isn't any evidence that we will not get much better, much more capable models as we continue to scale them across the axis of data and compute. Whether that takes you all the way to AGI or not, that's a different question. There are probably some other breakthroughs and advancements needed along the way, but I think there's still a long way to go in the scaling laws and to really gather a lot of benefits from these larger models.
How do you define AGI?
In our OpenAI charter, we define it as a computer system, basically, that is able to perform autonomously the majority of intellectual work.
Okay. I was at a lunch, and Robert Nishihara from Anyscale was there, and he asked what I called the Robert Nishihara question, which I thought was actually a very good characterization. He said, okay, so like you've got a continuum between like say a computer and Einstein. So you can go from a computer to a cat, you go from a cat to an average human, and you go from an average human to Einstein. Then they asked the question of, okay, so where are we on the continuum? What problem have we solved? And the consensus was, we know how to go from a cat to an average human. Like we don't know how to go from like a computer to a cat, because like that's the general perception problem. We're very close, but we're not quite there yet. And then we don't really know how to do the Einstein, which is kind of set reasoning.
With fine-tuning, you can get a lot, obviously. But in general, I think we're sort of, in most tasks, kind of like intern level, I would say. That's what I generally say. The issue is reliability, right?
Of course.
you can't fully rely on the system to do the thing that you want it to do all the time. And, how do you increase that reliability over time? And then how do you obviously expand the capabilities, the emergent capabilities, the new things that these models can do. I think, though, that it's important to pay attention to these emergent capabilities,
Yeah.
even if they're highly unreliable.
Yeah.
And especially for people that, are building companies today, you really want to think about, okay, what's somewhat possible today? What do you see glimpses of today?
Yeah.
Because, very quickly, these models could become reliable.
So I'm going to ask you in just a second to prognosticate on what that looks like. But before, very selfishly, I've got a question on how you think the economics of this are going to pencil out. Which is, I'll tell you what it reminds me of. It reminds me very much of the silicon industry. So I remember in the 90s, when you buy a computer, there are all these weird coprocessors. Here's like string matching, here's a floating point, here's crypto. And like all of them got consumed into basically the CPU. It just turns out generality was very powerful. And that created a certain type of economy, one where like you had, Intel and AMD and it all went in there. And of course, it creates a lot of money to build these chips. And so like you can imagine two futures. There's one future where generality is so powerful that over time the large models basically consume all functionality. And then there's another future where there's going to be a whole bunch of models and things fragment and there are different points of the design space. Do you have a sense of is it OpenAI and nobody, or is it everybody?
It kind of depends what you're trying to do. So obviously the trajectory is one where these AI systems will be doing more and more of the work that we're doing, and they'll be able to operate autonomously, but we will need to provide direction and guidance and oversee. But I don't want to do a lot of the repetitive work that I have to do every day. I want to focus on other things.
Right.
And maybe we don't have to work, 10, 12 hours a day, and maybe we can work less and achieve even higher output. And so that's sort of what I'm hoping for. But in terms of how this works out with the platform, you can see even today, we make a lot of models available through our API, and from the very small models to our frontier models, and people don't always need to use the most powerful, the most capable model. Sometimes they just need a model that actually fits for their specific use case, and that's far more economical. So I think there's going to be a range, but yeah, in terms of how we're imagining the platform play, we definitely want people to build on top of our models, and we want to give them tools so to make that easy and give them more and more access and control. So you can bring your data, you can customize these models, and you can really focus on the layer beyond the model and defining the products, which is actually really, really hard. There is a lot of focus right now on building more models, but building good products on top of these models is incredibly difficult.
Okay, we only have a couple more minutes, sadly. I would love for you to prognosticate a little bit on where you think this is all going,
Yeah.
3 years or 5 years or 10 years.
I think that the foundation models today obviously have this great representation of the world in text, and we're adding other modalities like images and video and various other things. So these models can get a more comprehensive sense of the world around us, similar to how we understand and observe the world. The world is not just in text, it's also in images. So I think that will certainly expand in that direction, and we'll have these bigger models that will have all these modalities. And that's kind of the pre-training part of the work, where we really want to get these pre-trained models that understand the world like we do. And then there is the output part of the model, where we introduce reinforcement learning with human feedback, and we want the model to do the thing that we ask it to do, and we want that to be reliable. And there is a ton of work that needs to happen here, and maybe introducing browsing so you can get fresh information and you can cite information and solve hallucinations. I don't think that's impossible. I think that's achievable. On the product side, I think we want to put this all together in this collection of agents that people collaborate with and really provide a platform where people can build on top of. And if you extrapolate really far out, these models are going to be incredibly powerful. And with that, obviously, comes fear of them being misaligned, having these very powerful models that are misaligned with our intentions. So then a huge challenge becomes the challenge of super alignment, which is a difficult technical challenge. And we've assembled an entire team at OpenAI to just focus on this problem.
So very last question. Are you a doomer, an accelerationist, or something else?
Let me say something else.
All right, perfect. Thank you so much. You're
Thank you.
fantastic.